You might have heard the term first principles thinking. Maybe you've seen some YouTube videos about it, explaining it like the most powerful way to think. And that might be true, but in this video, I would like to show you from the very foundation what it is, and also compare it to the opposite, which I like to call mechanism-free thinking. So I'm gonna start by showing this. So I have done a presentation here in Figma, so I'm gonna move through some slides, but I like to see it as two extremes. So first principles thinking and mechanism free. And I have a quote for both of them. So for first principles, it would be reason from basic truths and fundamental relations. And for mechanism free, it would be observe patterns and infer conclusions without regarding the underlying mechanisms. And that's kind of hard to understand, I guess, but I have the most simple example here to begin with. So for the mechanism-free thinking, I have this series, and you can see the value 6 is a bit more bold. So we have 0, 2, 4, 8, 10, 12, and by that we can infer that 6 would fit in here. So we're looking at the pattern. We don't really care about the mechanism or the rule, we just observe what is. And for first principles, it would be is 6 even? Yes, it is, and therefore it fits. So going through the actual logic. And I have some examples of the most basic use of this. So here I have a chat saying, do you think we could decrease our taxes by switching company type? Someone asks. And the answer is no. If that was possible, shouldn't we see others do that? And that's kind of reasonable, right? It's reasonable to think that if it was possible, others should do it, then it probably doesn't exist or is possible. But they didn't regard any of the logic or mechanism or laws or knowledge about it. They just made an observation. And so I've written, don't concern yourself with why, just look at the pattern. And for first principles, I have an example as well. It would be nice if this was about taxes as well, but we're going to get to why it will be possible to make the same example for first principles, because you can't actually use it to solve that example in the same way. So the one here is, our expansion of solar panels is great. It has worked in the US, France, and Italy. Should we expand to Kiruna, Sweden next? And the answer is probably not. Due to how north Kiruna is, the average solar power per square meter will be much lower, making it impractical. And hopefully you see a bit of a difference here. So they don't say others don't seem to do that, or making observations of what others do, or the statistics. They're just, the answer is reasoning that Earth is a globe, Kiruna is in Sweden, and the most northern Sweden. This means when the sun is shining, it's gonna hit Kiruna quite angled, and it's gonna be much less power per square meter, making it less practical than in other places of the world. So it's just fundamentally mechanism-driven thinking. And so hopefully that shows the kind of point of it. Moving on, I would like to say that most approaches are hybrids. So it isn't really that some are purely first principles and others are purely mechanism free. Most things are thinking that are like hybrids, somewhere in between. So I have two examples here where both of them are hybrids, but they are like placed differently on the spectrum. So the first one is others seem to go to college, so I should probably too. Very pattern observing, don't concern themselves with the logic, or it is logical, but in the mechanism. That's why I call it the mechanism behind it. And the next one is I want to be a pilot, so I need a pilot certificate. Therefore, I need to attend flight school. And you can see that it's a bit more like looking at how things work, what constraints are there, and based on those, what do I need to do? So a bit more first principles, even though it's kind of high level. It isn't first principles. It's like third or fifth or 100th. No, it's hard to say, but you get the point. It's not purely first principles, but still more of it. So I have here. So I'm gonna get more to like the pros and cons of both of them, and I hope you can see this. My zoom is a bit aggressive, so things goes outside, but if I begin like this. So I have written the predictive power of first principles. Make reliable predictions by not predicting at all. And I have an example here where it is electromagnetics plus coded information gives broadcasted messages, like, yes, sending information through space. And so these are kind of far apart, right? So it's like electromagnetics, a very it's one piece of understanding, and then how you can code information. And by truly understanding them and understand how they relate to things, you can, with those pieces, figure out how you can fit those pieces together in a different way, but still a working way, to get something completely new. So you can, like I have written here, understand the pieces and think about how they could be put together differently. I've also written gives a mechanical way to reason about possible solutions instead of inferring from existing ones. And yeah, so we can find something or predict or something completely new, but it isn't really a prediction. It isn't like a probability based or statistic based. It's a using the logic, its pieces, and building to it, deriving mechanically to it. So it can be very powerful in that regard. And that's why like many engineers and inventors, scientists are like big fans of first principles. So I'm gonna be a bit negative here, but I'm gonna be a bit nuanced later. So I will begin with like predicting by observation is limited. For the like, yeah, you can see the color scheme here, like the light blue is for the mechanism free. So we have A, B, and C, which is like within the scope, what we can observe. And based on those, which are like, let's call it reasonable solutions, there are another reasonable solution called D, which is like far apart. So maybe you could imagine like, let's say that A, B, and C are ways to like travel by horse. So maybe you do it a bit differently, maybe the setup is a bit different, but it's approximately the same solution, so they are close to each other. But there are other solutions which are completely different, like you could travel with a bicycle or a car or a plane, and of course now we just have a single outsider here, but they are like completely different, and by using observation it will be unlikely to find such outlier, if you understand what I mean, which makes it limited. So then comes the question, let's see if I can, why then not always use first principles? And I have written, if the logic is so deep that you can't feel the bottom, how deep is it really? So this is kind of weird, like, why do I show some man swimming here? And I've had this like mental image the probably past years. So with the first principles, the problem is like often the logic is just super complex. Like imagine like maybe social sciences or like economics or medicine. So you have a big system which just is so deep of complexity. And if you can't feel the bottom, you know, when you're swimming, how deep is it really? Is it 10 centimeters to the bottom? Is it 20? Is it a meter? A kilometer? It's kind of hard to judge. And the problem is that when the topic or subject is so complex that you can't really do the logic fully, so you approximate things or assume things, first principles give a kind of false confidence, which destroys its purpose. So often, like when you see economics and maybe medicine and the thing I mentioned, they don't do mathematical proofs. They don't have like logically proofs of what they are claiming. It's like statistics based, which is much closer to mechanism free. Of course, hybrids again, so it's a mix, but it is because in a system like economics, you can take pieces of it and make it, you can find the true logic in pieces, but the entire thing, especially when they're like humans, many of them, countries, laws, just the water is too deep. And many times, if you can't feel the bottom, like how deep is it really? So don't get false confidence, is basically my point. And so the next thing is then mechanism free isn't a bug, it's a feature. And allow yourself to not be concerned with the underlying mechanism, which is like quite powerful, because then you can have something like super complex, like a big system, and if you find patterns, then the patterns are there. You can do useful stuff without knowing exactly how things work. So I have like this black box illustration here where you don't have to concern yourself with the underlying mechanism. And so you can probably see how this is a feature. And it's like going back to the simple example where the tax thing, by just looking at others don't do this, so it probably doesn't work. You know, it's not a guaranteed logic, but in many cases it can be true. So it can be very useful. And they didn't have to concern themselves with the actual laws and stuff like that. So what I want to talk about next is first principles as compression. And so sometimes the logic is much more compact than the produced surface pattern. And I have drawn a kind of upside down triangle here with like grayed out points, and we have a surface and we have like an input. So what I mean by make sure that you can see compression, is that by many times a few simple rules and like relations can like produce something super complex. Like imagine the world, right? Imagine all the movement of things. Much of that can be described with just F equals ma, the Newton function or equation. And so it compresses the entire like reality, not the entire thing, of course, but much of the movements and acceleration and like Newtonian physics, it's just an equation. And many other times, like understanding the core logic in like a subject you're studying for school, the set of logic can like be applied in different combinations to produce seemingly different things, like maybe different questions on the test, but they boil down to a very small set of logic, which compresses the entire subject into something much more manageable. And so I think many people who do think a lot with first principles, they're really good with this because they can take something big and compress it to something much more manageable, which, yeah, like I think the Newton equation is like perfect for that. But in this example, it would be like this surface is like, yeah, we see that we're getting some stuff here. It's a green, and we have like a pink one here. The input is blue, but what is the rule really? Like it's kind of hard to say, but just looking at the surface, it would be much easier by having the rule. So yeah, I hope you get what I mean by compression and how that can describe seemingly complex things at the surface. So then the question comes, when to use what? And I've written here, when the logic is shallow enough, a mechanical derivation valuable for first principles. And for mechanism free, I've written, when the logic is very complicated but surface patterns manageable. So if I begin with the first principles one, it's like, as I mentioned before, it has to be like shallow enough, or you could focus on a certain part that also works, but it needs to be doable with first principles, and it's extra nice to use if mechanical derivation is valuable, because often when you are like an inventor or engineer, it's almost required that you can truly understand what you're doing to put pieces together differently to get to something new, or verify a thought that currently doesn't exist. So for the alternative, it's like, when the logic is very complicated but surface patterns manageable, as I mentioned with the examples of studies, like the economics, medicine, social sciences, and stuff like that, the logic is very deep, but patterns are often quite measurable and like useful. So one could imagine that a system that's so complicated with so many layers would like explode at surface level pattern. The complexity of the patterns would explode, making it like impossible to even find something. But in many of those systems, there are like constraints that forces the patterns to repeat themselves, to like show just make patterns repeat. And so from like measuring things, doing statistics and stuff like that, you can often come pretty far. And like that's what we see, right, in like many of the studies for those subjects. We see like, oh, these two things correlate, or the probability for this is that, and etc. Like that's what we see in those kind of studies. So it is very powerful there. And also another thing is, imagine like AI. You have a model that is capable enough to absorb complexity, and you train it by like giving it just huge amounts of data, and it absorbs the like logic and finds the patterns, which is very close to mechanism free thinking, if you understand what I mean. So yeah, hopefully that gives some kind of guide. I would say I myself is like, I'm a big fan of first principles, but I do a lot of work in like, yeah, engineering, programming, stuff like that. So it's very useful for me. And before doing this, it isn't really obvious, I think, to many people what the opposite would be. So I hope this has like explained that, and how powerful the opposite can be as well. Because I see many people like saying, "Oh, just do it by first principles; it's superior," and stuff like that. And while I do very much like it, but I hope this gave some kind of nuance to it. So yeah, that was probably everything for me, and I hope you liked the video. So bye.